Here's Precalculus Concept Lesson Video 4B. We're going to expand a binomial raised to a power, and there are 5 boxes, so let's get started right away. Okay, box number 1. I wonder if you remember how to raise a binomial to a power. Now remember, a binomial is just an expression that has 2 terms, like a plus b. That's a binomial. And we're raising the entire expression to an exponent. Okay, that's what this lesson is all about. Expanding a binomial raised to a power. Okay, so here we go. Hopefully you remember this. A plus b raised to the first power, or to the 0 power, that's just the number 1. Because anything raised to the power of 0 is the number 1. A plus b to the first power, well, that's just a plus b. Nothing too crazy about that one. A plus b squared literally means a plus b times a plus b. So hopefully you remember from algebra that this becomes a squared plus 2ab plus b squared. Hopefully you remember that. From algebra 2 again, if you take a plus b and you cube it, it means a plus b times a plus b times another quantity of a plus b. And when you do that, you end up with this. You end up with a cubed plus 3 a squared b plus 3 ab squared plus b to the third. Now maybe you remember that, maybe you don't, but you can always generate it by taking the quantity of a plus b and multiplying it by itself 3 times. But the cool thing about this lesson is we're going to learn how to expand all the rest of these to any power that we want. That's what the binomial theorem is going to be. Okay, box number 2 is a very, very important box. So I want to make sure that you copy this down and then I'll explain it to you. Okay, box number 2 is all about connecting the binomial expansions with this thing called Pascal's triangle with these things called the binomial coefficients that we learned in the previous lesson. So let's take a look at the binomial expansions. I showed you that a plus b to the 0 is a value of 1. A plus b to the first was just a plus b. A plus b squared is a squared plus 2ab plus b squared. And then, of course, a plus b cubed is all of this stuff right here. Okay? Pascal's triangle, something that you should have at least talked about in your previous math classes, looks like this. It is 1, and then 1, 1, and then 1, 2, 1, and then 1, 3, 3, 1. If I was going to write the next one, it would be 1, 4, 6, 4, and then 1. Well, how am I getting that? If I take any term and I simply add the 2 terms directly above to the right and the left, that's how I generate that number. So take a look at this one. The number 2 is nothing more than a 1 and a 1 added together. The number 6 is nothing more than a 3 and a 3 added together. So that's the connection. If I was going to go one more row, I would go 1, 5, 10, 5, oops, sorry, 10, 10. I missed another 10 there. 10, 10, 5, and then 1. So Pascal's triangle was discovered a long time ago, and you just simply add the 2 previous numbers up and above to the right and to the left. Okay? Well, here's the cool thing. Hopefully you guys are seeing this connection already, right? So notice that this is the number 1, and then of course that's the number 1. Well, notice that in front of the A there is a 1, and in front of the B there is a 1, just like there is here and here. In this expansion there's 1, a 2, and then a 1. A 1, a 2, and then a 1. Notice in the cubed expansion, a plus b cubed, I have 1a cubed, so there's my 1. I have a 3, there's my 3. I have another 3, there's the other 3. And then I have a 1 in front of the b cubed. So you guys, if I was going to do a plus b and raise it to the 4th power, the coefficients would be a 1, a 4, a 6, a 4, and a 1. Now here's something even crazier. The binomial coefficients. 1 over 0 is the number 1. 1 over 0 is the number 1, and 1 over 1 is also the number 1. 2 over 0 is the number 1. 2 over 1 is the number 2, and then 2 over 2 is the number 1 again. So where are these coming from? These are coming from the exponents. Notice, here's a 0, here's the 0 row. Here's the first, so here's a 1 and a 1. Here is power of 2, so notice I have my powers of 2 going up in sequential order, 0, 1, 2. Here's my power of 3, here's my powers of 3, and it's going up in sequential order, 0, 1, 2, and 3. So I know I'm saying a whole lot, but there is a connection between the binomial expansion, Pascal's triangle, and the binomial coefficient formula. And we're going to use all of this together to come up with the binomial theorem. Okay, box number 3 is an example. I'm going to show you how to expand this binomial using the binomial theorem. We want to take x plus 2 and raise it all to the third. Okay, I want you to understand that this literally means take x plus 2 and multiply it by itself 3 times. Okay? So that's what we're trying to figure out. Now, we could do this one at a time. We could do these two and then get that answer and multiply it by that and then get that answer. That's one way that we could do it. But we want to use what's known as the binomial theorem to expand this. Okay? So the first thing you have to realize is that if there are my exponent is 3, then I am guaranteed to have a value of, or I'm guaranteed to have 4 terms. So I will always have one more term than I have exponent, okay? And then all of these are going to be added together, okay? So I'm going to have 4 separate terms, and they're all going to be added together. The first thing that you want to do is you want to get the binomial coefficients. So we learned that in the other lesson, and we start with the exponent and we count up. So I'm going to have 3 over 0. And notice where I'm writing it. I'm writing it at the very beginning of each term. 3 over 1, okay, 3 over 2, and then finally 3 over 3. This is why I have exactly one more term than exponent. Next, you want to take the very first term of your binomial, which in this case is x, and I want to raise it to the highest power that I have, which is 3. And then I want to go all the way down for the first term. So x to the third, x squared, x to the first, and then finally x to the 0 power. Then I'm going to take my second term and I want to raise it to the powers going up. So what I mean by that is I'm going to go 2 to the 0, 2 to the first, 2 squared, and then finally 2 to the third. So a couple of things that you should notice here. One is that the sum of the exponents of my terms will always be the exponent that I've been given. So 2 and 1 make 3, 1 and 2 make 3, 3 and 0 make 3. You should always remember that part, okay? So now I have to just clean this part up. 3 over 0 is the number 1. X to the third is just x to the third, and 2 to the 0 is the number 1. 3 over 1 is the number 3. X squared is just x squared, and 2 to the first is just the number 2. 3 over 2 is also the number 3, because I know it from my calculator and from Pascal's triangle. And then x to the first is just x, and 2 squared is just the number 4. 3 over 3 is the number 1, x to the 0 is the number 1, and 2 to the third is the number 8. So cleaning all of this up, this whole term becomes x to the third. This whole term becomes 3 times 2, which is 6x squared. This whole term becomes 12x, so 12x. And this whole term just becomes the number 8. And we have clearly and effectively expanded x plus 2 all third to the third using the binomial theorem. Box number 4 is an example of expanding using the binomial theorem again. So let's set ourselves up for success. Since I have a power of 4, I know I'm going to have 1, 2, 3, 4, 5 terms in my expansion, and they're all going to be added together. I know this. I start with my exponent, and I say, okay, 4 over 0, and I count up. 4 over 1, 4 over 2, 4 over 3, and finally 4 over 4. Then I take my first term, which is x, and I raise it to the power of 4, and I count down x to the third, x squared, x to the first, finally x to the 0. Then I take my second term and I count up. So 1 to the 0, 1 to the first, 1 squared, 1 to the third, and finally 1 to the fourth. So not a big deal there. Okay? 4 over, now I just clean each of these terms up. 4 over 0 is 1. X to the fourth is just x to the fourth, and 1 to the 0 is just the number 1. 4 over 1 is 4, and then x to the third, and then a 1. 4 over 2 is 6 times x squared times 1. 4 over 3 is also 6, x to the first times 1. Oh, sorry, 4 over 3 is the number 4, excuse me. And then finally 4 over 4 is the number 1, x to the 0, and then 1. So cleaning all of this up, I get x to the fourth plus 4x to the third plus 6x squared plus 4x plus 1. And we have expanded using the binomial theorem. Okay, box number 5, I just want you to ask me about the 2 warnings in class tomorrow. Again, box number 5, just ask me about the 2 warnings in class tomorrow.